Let's test this audio. How's this? Not getting any audio, but this is showing that there's audio. Let's test this audio. How's this? Not getting any audio, but this is showing that there's audio. Test this audio. Alright, let's see if I got that. Are you there? Noise suppression. Let's try that. Test 1, 2, 3. Test 1, 2, 3. That's not going to get it. That's. Test 1, 2, 3. Like I'm in a can. Now, am I in a can now? Like I'm in a can. Go this way. All right, let's try this one. All right, test 1, 2, 3. Nothing. Are you there? All right, let's try this way. How about now?
All right, we may have solved it. So let me see if I can complete this problem we started the other day. I am going to test the mute. So apparently the mute button does work. So if I start to cough, I'm going to mute myself with this red button. So we started this with the concept that we found out that So we started this with. Am I going? I guess I. All right. So we had a velocity here of 4. We had a velocity here of 4. What we found out is omega AB was equal to 0. And I think if we look back, we may find that the omega, which this AB, we'll call this C, would be equal to the velocity over r, or since this is a velocity of 4 and that's a velocity of 4, we would have 4 divided by 2, this 4 divided by that 2, which will give you 2. So omega BC would simply be equal to 2. Now, what we'll do is we'll go through this, and I'll pick another problem later. We'll go through it as well. Acceleration of A is equal to the acceleration of A relative to B plus the acceleration of B. And the acceleration of A is going to be alpha AB, this, minus omega AB squared R A to B plus the acceleration of B, which we don't have right now. So this is the set of equations. This part is this one, and this, of course, is this. And so as a result, we have a couple things that we know. One is we know that this is 6, and it's I, and he did not put coordinate system on it, but by nature, you're going to have this. And what we'll do is IJK. I think I did this mostly on the board. And this will be and then the RA. So if I'm looking for this vector right here, This is R pointing to A, originating from B. Same thing that sits right there. And that is a 2 cosine 30. So what I'm doing here, okay, looks like I'm stuck on this. Let's see. Well, it looks like I'm stuck on this color. 2 sine of 30, and then 0 minus, now omega AB we found from last time. If you look back in the lecture, it was 0. So it doesn't really matter this. And then we have the acceleration of B. So so 6I equals to I 2 sine of 30. That's is the same thing as 2 sine of 30. It's just a shorthand way of doing it. To cosine 30. This is the two values there, but the thing is, doesn't matter. This will be plus, this will be minus, so it'll be minus alpha AB 2 sine of 30 I, and then this will be plus minus, but then the minus will go together with the other minus and give me back a plus alpha AB 2 cosine 30 J, there's 6I. Now, the fact that we ended up with a rigid, let's see, it will not allow me to select anything but this color now for some reason. Let's see if I hit the escape button, it does it. Oh, it does. Okay. So it will let me do that. So the fact of the matter is we had rigid, this link right here was moving in rigid body motion to the right. We end up with this term right here, which we're stuck sitting here. Now, I can't go any further because I don't know what that value is. However, technically speaking, depending on the way you look at it, okay, again, hit the escape key. This can be thought of as a link. And so that's what we're going to do. And it will have its own. Now I'm drawing it this way. And the reason being is because that's the positive direction. Okay. So I have to go in and do the motion on that link. Acceleration of B on this link is equal to acceleration of B relative to C plus the acceleration of C. However, this acceleration of this C point right there is in fact 0. So really what you've got is you've got this acceleration of B is equal to alpha BC cross R B from C minus omega BC, which we have, and its magnitude squared R BC. Now the term here would generally be the acceleration of C, but again it's 0. So this is the term that will eventually be put in right here, and then we'll solve all this. But for the moment, I, J, K, 0, 0. I'm going to assume it in a positive direction. The vector that starts at C, ends at B, is one that goes directly north, and it is a length of 2. So it is 2, moves nowhere in the X and nowhere in the Y. And then I'll just go ahead. Okay, so it is true that this is in the negative direction. So if you were to write it, omega BC as a vector would be minus 2K, indicating that it is rotating in that direction right here. And that's kind of what we've got. But it doesn't matter the sign, because either way, centrifugal doesn't go that direction. It goes back towards the center of the coordinate, which is 2J plus 0, but I don't really want to write that. So it turns out the I component is the only thing that will admit. If I do a cofactor expansion, eliminating this one and this one, I only get the 0, alpha BC, 2, and 0. If I do a minus J, I'm eliminating this and this one, and that will give me 0, 0, alpha BC, and 0, which is in fact is 0. So in fact, you didn't even need any of this. And then 2 is 4, and then 8, so minus 8J. So you end up with plus, a minus, or a minus 2, alpha BC, I minus 8J. That is the acceleration of B. Now, if you go put this one in here, you will get this. I'll do a copy. I'll drop it right there. Assuming I have all my terms. Looks like I do. And then I have this one. Do a copy. I'm going to drop it about right there. Move it up a little bit. And this is the equation I have. So again, taking a close look at what I just did. What I actually did. Let's see if I can zoom back out and then zoom back in. Okay. I solve this equation from the first link. Then I started in on the second link here. ended up solving for this. And I took the acceleration B and stuck back in here. I copied a portion here, and I copied this portion over here. Now, I can go in and break it down into the I component and then the J component. On the left-hand side here, let's do it this way. Here's my I, and my I. So I have 6 is equal to minus alpha AB 2 sine of 30 and then minus 2 alpha BC. Then for the J component, I have nothing over here. So there is no J over here. There's a J right here. And there's a J right there. So 0 is equal to alpha AB 2 cosine of 30 coming from right here. And then minus 8. And so you have 2 equations and 2 unknowns. The first thing you can see, alpha AB, just seems interesting to me that that's the first one you can pull it off of. But that's okay. Is equal to 8 divided by 2 cosine of 30. That's basically what he was asking for in the problem. Let's pick another one and do that one before we finish. I'm going to let this lecture kind of lap over past the hour because I was having some pretty bad technical difficulties. In fact, I did not have I'm going to put it on the intro scene for a second. I do not know what the heck is going on. Come on. What is this? Sorry for the delay there for a second. I don't know what was happening. Now I see it was trying to launch this thing. I can't get rid of it. What in the world is going on? I do not want that there. Okay. Jeez. Well, mute the volume for a while till this comes up. Oh gosh, here we go. Boy, that took forever. Let's see. Oh, that one looks interesting. I like that one. I might come back and do that one. That one looks interesting as well, though. Let's see, that is 18, 19. Wait, see? I like those two. I'll definitely do those two. That one's good. This that one actually may be the most interesting. All right, I'm gonna do that one. I like that one because it has a very interesting look to it. Oh, wait a minute. Okay, let me. Everything's pretty slow. I don't know why. All right. So he wants to know the velocity and the acceleration in point C. Sorry, I forgot to put it on mute. I thought I had it on mute. Sorry. All right. One of the things we'll have to remember here is this could be treated as an entire link here. So that's an entire link. Now, why does that even matter? Because if you write the equations, let's focus on A, then B, then C. What is interesting here is like the velocity of A is equal to, or let's do the velocity of B is equal to the velocity of B relative to A plus the velocity of A, right? And this can be written as omega AB cross R BA. Now, the interesting thing in here is that okay, plus velocity of A, which this time you'll have it directly and you can put it in a little bit different than before. But if you start writing down the velocity of C, it's on the same link as this. This whole thing is a link, right? And you may first say, okay, that would be velocity of C relative to A plus velocity A. Now, A and C are together on the same rigid link. It's not going to break this little elbow piece. And you might write CA cross RC relative to A plus velocity A. However, this omega and this omega are the same thing. So it might be better suited to write this as ABC. ABC. In that, it's the whole link ABC. It's everything here. That makes the problem quite interesting. One, because this is going to the right or the left, and therefore, because of that, that can help you define what omega ABC is. But you don't know that this is going a particular way. So the first thing let's do the upper one. But before we do that, we're going to do something interesting. I'm going to come in here and say, I know this goes to the right or the left. It's going to go this way, or it's going to go that way. But a perpendicular is going to go straight up. I know this point for sure is going that way, so a perpendicular there goes this. When I say a perpendicular, I mean perpendicular to the velocity. Perpendicular to the velocity. Draw those lines. Here's your instant center. This is where this link appears to be rotating about. Now, if we zoom in on this, now we need to know a couple of, and let me see if I can maybe tidy this up so it looks a little better. Okay, here's my velocity. I'll just assume it one direction. Take a 90-degree line from there. Try to go straight up. Now, there used to be this thing, they had a ruler. Yeah. Okay, so let's go ahead and make use of these things. Take a ruler, make it go perfectly straight up. Okay. And just so it's easier to see things, I'm going to go, come on. Okay, that's a little much. There we go. Now, we know the velocity here goes down. We know the velocity here is going to go towards your left or right. Technically, it really doesn't matter. This, the point of intersection, is just called the instant center. Now, we look at this. He has 60 degrees here. So I'll sort of mess with this, and that is this distance is 0.6, which is this, times, and its cosine of 30. And this distance right here, 0.6 sine of 30. Let's see. I'm going to go ahead and come up with those numbers using a calculator over here. 0.6. Whoa. Let's see. Why did I say 30? I must apologize about that. I caught that cough. Okay. That I'm sorry about. Okay, take 60. You're going to cosine it. So this one's going to be, it's 0.3. And this one's going to be the 0.5195. 6. And I know I shouldn't do this, but I'm going to carry a few extra digits. Doesn't look right to me. As a matter of fact, these are totally both flipped. So I can definitely tell I had it the right the first time, but it wasn't related to this. But let me fix it again. And here's the way I'm going to fix it. I'm going to take this, slide it out of the way. Now, take this one. I'm going to move it to right here. Go back. Sorry about the backwards reference there. Now, let me further explain this so it's not as confusing. In other words, the triangle looks like so, where this, of course, is your 60, and so it you start seeing that. Oh, wait a minute. That is the larger of the two. So this distance is to right there, and that's the distance to right there. So I'm sorry about the flipping of the angles. I flipped them in my brain and then reflipped them by switching 30. What happened in my brain was I saw a 30 degree here. That I apologize about. So in fact, the end result is this is your rotation. This is your omega ABC. This, in fact, is the velocity here. So V is equal to omega R. This V is equal to this omega. The R is the distance from this point to the center of rotation. And so what you end up with is 1.5. That's the meters per second. Omega, that's what we're looking for. And we'll just go ahead and say it's ABC. And this is 0.3. And that would tell you that omega ABC will be, I'll go ahead and calculate it here on my phone. Being 5. Now, it's an independent way of solving it. And I'm going to leave this as it is. What I'll do is I'll continue with this, and I'll say I'm going to check something and say, what is the velocity of B? Velocity of B, we're going to check all this with this. So this is the instant center method here, and this is going to be your standard vector method. Omega ABC times R from B, the instant center. Well, we've already figured out that this is going to be 5, and this RB to the instant center is 0.5196,152. Multiplying times 0.5196,152. Or looks to me like it's close enough to 2.6. Now here's what's so funny. Not funny in a bad way or anything. But if I were to take my ruler and do the best I can about drawing a very dotted line to here is 23 degrees. And then try to do the best I can about trying to make it perpendicular. This will be the velocity of c. Can we figure this one out? Actually, you can. I may have to mark around on the drawing a little bit, but that's okay. If you look at this, and this is 60, and this is perpendicular, this must be 30. If that's the case, 30 and 90 get you back to another 60. If in fact that's the case, then you have an oddball kind of thing here, in that that's not a 90 degree up here. So you have a triangle that looks like this, which has no 90 degree to it. So the question is, can you determine that distance right there? Well, let's see. I know that's 60. Let's see. I know this distance. I could actually draw a vector from B to C, and in that vector from B to C, I could figure out and subtract those two. In other words, how can I do that in a drawing here? I know how to do it. I will copy this. I think I still have it in the copying bank. Yeah. However, I didn't want all that. I guess that would be okay. Okay. What I'm saying is I can draw that vector. I can draw the vector to here. And then I'll call this one, well, this one will be pretty much simple. R drawn to C originating from B. And since those were 90, this was going to be 30 down here. So R CB is going to be minus 0.5 cosine 30I plus 0.5 sine of 30J. Now, this vector is going to be, so that's going to be that. This vector from before, we're just going to call it RB. What did I have? Did I have a term for that? That's actually instant center. Going to the instant center originated from B is going to be that length, which was 0.5196152. Okay. 519 6152. And that is going to be AJ. If I want to know this one, I can say R2 no. How about that? You can write this equation pretty simply and say R instant center from B plus R to no is equal to RC relative to B. I think I caught the cough there before I sent it down your ears. R to no minus R instant center to B is simply I plus sin 30 minus 0.5196152, and that's J. Let's check this out, and the way I'm going to do that is see if I have octave on this machine. Apparently I do. This means I don't need to use the I do not need to use well, I brought it up, but then I didn't put anything in it. Okay. I'll just say R2 is equal to minus 0.5 times cosine degree of 30. And then I'll put them in a vertical row. 0.5 times sine degree 30 minus 0.5196,152. Oops, and then I gotta put the bracket. Wait a minute. Okay, so there you go. So the vector points back to the left and down. Let's see, back to the left and down. So that seems pretty reasonable. And it turns out, what is the size of that thing? Norm R2 is just going to be 0.51. Length of R2K is equal to 0.51 009. So this means that go back here and say velocity of C will equal to omega ABC times the R to the C from the instant center. And that is not going to be that, so it's going to be 5 times 0.51009. And that's going to be 2.55 is equal to 2.55. That's going to be the velocity at C. Okay, let's see if we get all these. And at the end of that, we're going to call it quits. We're going to finish this up next time. In fact, well, I'll just keep going. A few more minutes. Actually, what I might do is just draw it to a close. I know we had technical difficulties. I worked it out. We will continue this on Wednesday.